Hey students, on this clip we're going to be going over question 1 and 2 of the GCE Core Mathematics C1 Advanced Sub exam for January 2012. Okay, if you want to get access to these documents, you can go to www.edexcel.com to gain access to it. Alright, before we start, I just want to commend you for taking the time to view this video. Hopefully you do well on your examination. Alright, let's take a look at question number 1. It says, given that y equals x to the 4th and r plus 6x to the 1/2, find the simplest form of a dy by dx and b the indefinite integral of y dx. Okay, so for part A you get 3 marks, and for part B you get 3 marks. Alright, let's go ahead and take a look at the solution for part A. For part A, it's testing your knowledge of the application of the differentiation rules. So let's start with the original function. Y equals x to the 4th plus 6x to the 1/2. Okay. Now these are both, we have the sum of 2 powers, so we're going to use the power differentiation rule to differentiate these. Okay. So what is the power rule for differentiation? If you have x to the n, if you want to take the derivative of x to the n, it's simply going to become n times x to the n minus 1. Alright? So how do you get this from here? All you simply do is you bring the power to the front, and then you subtract 1 from the power. You reduce the power by 1. Okay, the power becomes a coefficient, and then you reduce the power by 1. That's the procedure we're going to be applying to these 2 powers. Alright? So we're going to do this term by term differentiation. So dy by dx is going to be we're gonna apply let me just show you how it works. So we're gonna do the dx of x to the 4th plus d by dx of 6x to the 1/2. This helps you see that we're differentiating these 2 terms one at a time. Okay. So dy by dx, applying the power rule here, this 4 will come to the front. You have 4x, and then you subtract 1 from the power, so 4 minus 1. Okay. The same procedure here, this 1/2 comes to the front. Oh wait, there was a 6 there before, so what do? You simply multiply the 6 by that power that's coming to the front. So 6 times 1/2, and then times x. Now you reduce the existing power by 1, so 1/2 minus 1. Okay? Alright, we'll simplify this. That will tell us what's dy by dx is. So let's go ahead and simplify this. We'll have 4x to the 4 minus 1 is 3. Plus, if we reduce this, we just divide by 2. 2 goes into 2 ones, 2 goes here 3 times. So we're going to have 3x to the 1/2 minus 1 is negative 1/2. Okay? All you do there is you just find the LCD. You can write this as negative 2 over 2. And when you subtract, we have negative 1 over 2. So that's why the power here is negative 1/2. Alright, so dy by dx is 4x to the 3rd plus 3x to the negative 1/2. So there goes the answer for part A. Alright, so let's take a look at part B. So for part B, we're doing the opposite of differentiation, which is anti-differentiation or integration. So we're looking at the indefinite integral of y dx. Okay, so let's rewrite the function. Y equals x to the 4th plus 6x to the 1/2. In this case, we're going to do a term-by-term integration of both terms. Since these are 2 powers, we're going to use a power rule for integration. So what is the power rule for integration? Let's take a look at it before we apply here. If you're integrating the power x to the n dx, it's basically x to the n plus 1 divided by n plus 1. Alright? So whatever the power is, you add 1 to it, and then you create a denominator and add 1 to the power and insert it in the denominator. Alright, so that's how you find the antiderivative of power. And since it's an indefinite integral, you also have to add a constant c. Alright, so we're going to apply this rule to these 2 terms, and then we will simplify it. Alright, so let's go ahead and find what the integral of y is. So the integral of y dx is the integral of x to the 4th dx plus the integral of 6x to the 1 half dx. Okay? Now let's go ahead and apply the power rule for integration. For the first term, x to the 4th is going to become x to the 4 plus 1. Remember, you just add 1 to the power. Divided by the denominator is what you get when you added 1 to the power. So it's also 4 plus 1. Plus 6x to the, now this 6 can be factored out. Okay, it plays no role. We just focus on the variable right here. 6x to the 1 half plus 1 divided by 1 half plus 1. Okay, applying this rule again, plus our constant c. Alright, so that's what you get when you apply the power rule for integration to integrating these two terms, alright? Now let's simplify them as much as we can, and that will be our final answer. So this is going to become x to the 5th divided by 5 plus 6x 1 half plus 1 is 3 over 2 divided by 3 over 2 plus c. Okay? So this doesn't look good. We have a fraction in the denominator, so how do we resolve that? To simply resolve that, all we do is we can multiply the numerator by the reciprocal of the denominator. Okay? So we're going to have x to the 5th over 5 plus this, we'll reciprocate this and multiply by the numerator because that's the same thing as dividing. So we're going to have 2 over 3 times 6x to the 3 over 2 plus c. Okay? Alright, so to finish this up, we just cross reduce. 3 goes here 1, 3 goes here twice. So the final answer will be x to the 5th over 5 plus, multiply this 2 and 2, 4x to the 3 over 2 plus c. And that is the indefinite integral of y dx. Alright, so there goes your second result. Alright, now let's move on to question number 2. In question 2, we're going to apply our knowledge of the simplification of surds and also the rationalization of surds, okay? So let's start with the A part. We're asked to simplify the surd root 32 plus root 18, okay? Now you want to note that if there's no number in front of the square root, we're taking the second root. Okay, so there's, think about it, there's an imaginary 2, little 2 right here, we're taking the second root. Alright, so to give our answer in the form a root 2, where a is an integer, we have to simplify these two as much as possible, and then we can combine them if we can. So to do that, before I do that, I want to just go over a rule with you. For simplifying surds, if you have the square root of a squared, what does this become? Remember, there's an imaginary 2 here, so this is the square root, this is a square, your inverse operation, so they cancel each other out, and your final answer is a. Okay? So what I'm going to be doing is I'm going to decompose these two completely, and I'm going to create squares, and anywhere I have a square, they're going to reduce into their root. Okay, because we're taking the square root of a square. So let's start out with 32. What does 32 decompose into? So we have 32. I'm going to take out just prime factors because I'm looking for the prime factor decomposition of 32. I take out 2, I'm left with 16. Take out another 2, I'm left with 8. Subtract another 2, I'm left with 4. Take out another 2, and I'm left with 2. So I have 1, 2, 3, 4, 5, 5 2s. So it's 2 times 2 times 2 times 2 times 2. Okay, since we're dealing with square roots, I'm going to just group the squares, okay? We're taking the square root of this whole expression, so I'm going to take these first two as a square, the second two as a square, and that one stays alone, okay? So this expression becomes the square root of 2 squared, the first 2, times 2 squared, the second 2, times 2. Okay? Now we're going to apply another rule of surds. If you have the square root of a times b, it's the same thing as the square root of a times the square root of b. Okay? And I'm going to apply that rule to these three terms. So we're going to have the square root of 2 squared times the square root of 2 squared times the square root of 2. Okay? Now, if you look at this, you notice the first two, this is a square, this is the square root of a square, so the square root and the square cancel out. In this case, the square root and the square also cancel out. This one doesn't have a square, so it stays the way it is. So this is now going to become 2 times 2 times the square root of 2. 2 times 2 is 4, 4 root 2. So the simplified form of the square root of 32 is simply 4 root 2. Okay? Alright, now we're going to apply the same procedure to the square root of 18, and then see if we can combine both terms. Alright, so for the square root of 18, we're going to break 18 down complete as much as we can, using only prime factors. Okay, so 2 comes out of 18 9 times, and then 3 comes out of 9 3 times. Alright, so 18 is 2 times 3 times 3. Okay, so we're taking the square root of that whole thing. Now, since we're dealing with square roots, I have to group squares, or pairs of common prime factors. So I group these two together. So I'm going to have, let me use the reflective property of multiplication. I can write this as 3 squared times 2. Okay? Now, using this property we discussed up here, we're going to have the square root of 3 squared times the square root of 2. Now, since square and square roots are inverse operations, these two cancel out. So we're going to have 3 root 2 as a simplified form of root 18. Okay, so this becomes 3 root 2. Okay, now what we're going to do is, since the radicals are identical, I can combine them. So I'm going to have 7 root 2 as the simplified form of the third root 32 plus root 18. Okay, so there goes the answer to the first part. Alright, let's move on to question number, the B part. So for the B part, we're going to be simplifying the third, root 32 plus root 18 divided by 3 plus root 2. Okay, so if we examine this problem closely, we'll notice that the numerator is exactly the same thing as part A. So all I'll just do is I'll just insert the simplified form for my numerator. I don't need to do the work again. So that's going to be 7 root 2, because that's what we got in the A part. Alright, 7 root 2 divided by 3 plus root 2. Okay? So we're not allowed to have square roots in the denominator. So to get rid of this third in the denominator, turn it into an integer, I have to multiply by its conjugate. Okay, by its conjugate. So to do that, all I'll simply do is I'll multiply by 3 minus root 2 in the denominator, and 3 minus root 2 in the numerator. Okay? So how on earth did I come up with these two thirds? All you do is you just switch the sign in the center. That's all. That's how I came up with these two. You just switch the sign in the center, multiply the numerator and the denominator, and then this will cause the third in the denominator to change into an integer. Okay? So let's go ahead and expand this. We're going to distribute the denominator. We'll multiply in this order, and then the inner terms like that. Okay? And then the numerator, all we just simply do is we just multiply 7 root 2 to both terms. Okay, so let's go ahead and do the multiplication. For the numerator, we're going to have 3 times 7 root 2. You multiply the integers, okay? Minus 7 root 2 times root 2. Okay, that's for the numerator. And then for the denominator, we're going to have, let me just break down the steps so you don't get confused here. We're going to multiply, we have 3 times 3. 3 times 3 minus 3 times root 2, which is 3 root 2. And then minus positive root 2 times 3, which is plus 3 root 2. Minus root 2 times root 2 is just root 2 squared. Okay? Alright, now let's simplify that. Looking at the numerator, what we'll have is 21 root 2 minus 7 times root 2 times root 2 is root 2 squared, again, divided by, and the denominator 3 times 3 is 9. These two surds are opposites, so they add out to 0. Minus root 2 squared is just 2. Okay? Alright, let's keep on simplifying. In the numerator, we need to get rid of that root 2 squared, so it becomes, we'll have 21 root 2 minus 7. Now root 2 squared, these are inverse operations, so they cancel each other out. 7 times 2. Okay? And then the denominator, 9 minus 2, 9 minus 2 is 7. Okay? So we're going to have 21 root 2 minus 14 divided by 7. Alright? So to finish this up, we just simply divide the surd and the integer by 7. So we're going to write it in following format. We're going to have 21 root 2 divided by 7 minus 14 divided by 7. Alright? So 7 goes into 21 3 times, so we have 3 root 2 minus 7 goes into 14 twice. So we have 3 root 2 minus 2. Okay? So that goes the answer to the B part. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here so you can get updates to other parts of this release test questions. More collection of tips can be found on mycourseserve.com. Thanks again and have a wonderful day.